Question 5. Right, let's have a look at this diagram first, and let's agree that we're likely to use the intersecting chord theorem. Okay, and now let's have a look. A, D, B, and E are points on the circle. Yes, they're labelled. A, F, B, C, O, E, C, and O, F, D are straight lines. Yes, they look like it. AF is 7, that's marked. FB is 4, that's marked. BC is 5, that's marked. FD is 2, that's marked. And CE is X, that's marked. Find the value of X. Show you're working clearly. Okay, right now. If we're going to use the intersecting chord theorem, we're obviously eventually going to use this line here and this line here. We're probably eventually going to use those intersecting chords, aren't we? Okay. And I notice the intersection is outside the circle, so that's quite fun. But before we do that, we're going to need to find out more side lengths, because before I use this chord here, I could really do with knowing the radius of the circle, these two lengths, or the diameter of the circle. So let's just go back a second and let's have a think about this chord here. Okay. All I know about that so far is that part of it is 2, and then the other part is the rest of the diameter of the circle. Let's call this point Z, just so we've got some way of referencing it. So if I think about DZ, now I could think about DZ alongside, alongside what? Well, I could think about it alongside AB. Look, there are 2 intersecting chords, and I know the lengths I need for AB. So let's set up that equation there, shall we? So I'm going to have AB and DZ. And I've got F and F and F and F multiplied and multiplied. So there's the intersecting chord theorem formula set up. Right, AF is 7 times BF is 4 equals DF is 2 and ZF, I don't know what that is, I'll just call it ZF. But look, I can find ZF now. 28 equals 2 times ZF. So ZF is 14. Right, so all the way from here to here is 14, which means that the whole of the diameter is 16. So I know the diameter of the circle is 16, the 14 plus this 2 here. So that means I now know the radius is 8. Now I think I'm in a position to use this intersecting chord here. These 2 intersecting chords here. I think I'm in a position to use that one because I know that this is 8 and that's 8 and that's X. And I think I can combine that one with AC, with this one. I'll draw it in blue. AC, right. So this time I have got chords as follows. I've got chord AB, and I've got chord, I haven't given this one a name, I'll call it Y. And I've got chord YE. And they intersect at the point C. C, 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 multiply, multiply. Right. Now can I fill in the gaps here? Let's have a think. So A to C is 7 plus 4 plus 5, 16. Times B to C is 5 equals Y to C. Well, Y to C is 8 and 8 and X, isn't it? So that's 16 plus X multiplied by EC is X. Look at this. I think I'm going to get a quadratic equation. Let's have a look. So I've got 80 equals 16x plus x squared. So I've got x squared plus 16x minus 80 equals 0. So can I factorise this? I think I can. Let's have a look. Got to multiply to 80 and add to 16. 20 and 4 maybe, because one of them's plus, one of them's minus. Let's have a look. 20 and 4 plus 20 minus 4. That's going to give me minus 80, and it gives me plus 16. So look at that. My solutions are x is 4 or minus 20. So are there two answers then for x? Let's have a look at the diagram. Does it make sense for x to be negative 20? It doesn't. X is clearly a positive value. So x is minus 20 is not valid, meaning that the answer is that x is 4. So in question 5 there, we use the intersecting chord theorem twice. Once where the chords intersected within the circle at the point F, and on the second occasion where the chords intersected outside the circle at the point C.